Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is applications of trigonometry. Previously we discussed about different trigonometric angles and their identities. Here we apply those principles to real applications. Previously, we told that trigonometry can be used to measure height of buildings without really climbing on that. Here is the example how to do it. We have considered a building here and we find a user here who is able to measure this particular angle theta by focusing on the top of the building. The distance of user from the base of the building can be easily measured. So if through some instruments he can measure the angle theta, then we know one angle and one distance. So we can easily compute the building height by simple formula of tan theta. Opposite side by adjacent side. If theta is known, distance from the building is known, then height of the building can be easily computed. Now what is this angle theta? It is called as the angle of elevation. That is the angle between the horizontal and the line of sight. This red color is called the line of sight. This theta is called as angle of elevation. Let us now define angle of depression. Consider a lighthouse here which is keeping an eye on the ship coming towards it. The angle theta measured from the horizontal to the line of sight is called angle of depression. Similarly, if we know the height of the lighthouse and if we know this angle theta, we can easily find the distance between the lighthouse and the ship. Let us try to understand through some examples. The angle of elevation of the top of a building from the foot of the tower is 30 degrees. Let this be the tower, AC be the tower and DB be the building. So the angle of elevation from the foot of the tower to the top of the building is 30 degrees. This is given as 30 degrees. Similarly, the angle of elevation of the top of the tower from the foot of the building is 60 degrees. And it is given that the tower height is 40 meter. So AC is 40 meter. Find height of the building. We need to find DB. Now how to proceed, students? For such problems, we should first locate those triangles where one side and one angle is given. For example, in triangle ACB, which is a right angle triangle at C, we are given AC as 40 and angle B is 60 degree. Angle ABC is 60 degrees. So in this triangle, we can find CB or we can find AB. Now which one we should find? If we look carefully, we find that CB is common to another triangle DCB. So if we know CB and if we know this angle 30 degree, we can find DB. So finding AB is of no use. Let us try to find CB first. In triangle ACB, tan 60 is opposite side by adjacent side. So 40 by CB. What is tan 60, friend? It is root 3. So CB will be 40 by root 3. This distance is 40 by root 3. I suggest that we should not further simplify this because this is still not the final answer. So we'll keep it as it is. Now in triangle DCB, now CB is known. Angle DCB is 30 degrees given. So we can easily find DB. Now tan 30 is DB by CB. So DB is CB into tan 30. What is CB, friends? We already computed 40 by root 3, and what is tan 30? 1 by root 3. So root 3 into root 3 is 3. So dB is 40 by 3. This is our final answer. Let us take another example, friends, which is dealing with the angle of depression here. From the top of a watchtower or lighthouse, which is 60-meter high, this is 60-meter high AC, the angle of depression of two ships are in 30 degree and 60 degree. So these are the two ships, point D and point B. So from the watchtower we see that this angle is 30 degree, angle of depression is 30 degree, and another ship it is 60 degree. Find the distance between the ships. Now friends, for angle of depression we told it is measured from the horizontal line. So horizontal line to line of sight is 30 degree. Now this line, dotted line, is parallel to CD, and this is AD is a transversal. So this angle is 30 degree, then angle CDA is also 30 degree. Alternate angles. Similarly, if this angle is 60 degree, then angle ABC is also 60 degree. Alternate angles for this dotted line and CD are the parallel lines, and AB is the transversal here. Now let us consider triangle ACB first. Here we have this side information and one angle information, so we can get CB. And similarly in this bigger triangle ADC, we have the 60 as this distance, and we can find CD by using this angle information. So CD minus CB will get distance BD. So this we should visualize first, friends, before solving it. Once we know what we are doing, we can easily do the calculation. So in triangle ACB, tan 60 is AC by CB, which is 60 by CB. Now CB is 60 by tan 60, and tan 60 is root 3. So CB will be 60 by root 3. So we have got this distance. Now we consider the bigger triangle ADC. So tan 30 there is 60 by CD. So tan 30 is what, friends? 1 by root 3. So 1 by root 3, so CD will be 60 root 3. Correct? CD will be 60 root 3. Now BD is CD minus CB. We have already computed CD and CB. Will get 60 root 3 minus 60 by root 3. This can be simplified to 40 root 3. So the distance between ship is 40 root 3. With this, friends, we conclude the chapter. I request you to please subscribe my video and give a thumbs up. This will motivate me to make more such good videos for you. Thank you very much, friends.